Okay, I'm going to solve this question in this video. A ball P of mass 0.5 kg loses 1/4 of its velocity when it makes a head-on collision with an identical ball Q at rest. Let's say this is my ball P. The mass is 0.5 kg. That is to say the mass of my ball P moving with a speed of U1, we don't know that yet. And then we have this ball Q at rest. Both balls identical, means they have the same mass. So the mass of my second ball is also 5 kg at rest. That is its initial velocity U2 is given as 0. Now after the head-on collision, ball P loses 1/4 of its velocity. That is to say, V1 equals 3/4 of U1. That is what is left. Okay? So which means the final speed of ball P is 3/4 of initial speed of ball P. And that kind of collision is not perfectly elastic. It is a type of inelastic collision because here we're going to see later that the kinetic energy of the system of masses will not be conserved. The final velocity of Q is 3 meters per second at rest. After the collision, Q moves off with a speed of 3 meters per second in the original direction of P. Okay, let's draw a diagram to show the situation of the two balls after the impact. Okay, so let's call this one ball P. Let's call this one ball Q. After the impact, we see ball Q moving in this direction with a speed of 3 meters per second. Okay, so let's find we have to calculate the initial velocity of ball P. That is, this is unknown. Okay, so let's use the momentum conservation equation. That is sum of the momentum or momenta before collision m1 u1 plus m2 u2 is equal to the sum after collision. Let's apply this to solve this question. Okay, so since the second ball was at rest, so u2 is 0, this term is 0. So what I have here is 0.5. Or since the two balls are identical, it means that the masses m1 is equal to m2. No, they cannot cancel out. This can cross out this, can cross out this. So I have u1 is equal to v1 plus v2. My u1 is equal to, what's my v1? 3/4, 3/4 u1. What's my v2? 3. Why am I taking it as positive 3? Because it's moving in the original direction of P. P was moving along the positive x-axis. Collecting like terms, what do I have here? I have u1 minus 3/4 u1 is equal to 3. u1 minus 3/4 u1 is 1 over 4 u1 is equal to 3 over 1. So when I cross multiply, I have u1 is 3 times 4, which is 12 meters per second. So that gives the initial velocity of ball P before the impact. Now, is it possible to check whether this collision is actually elastic or inelastic? Okay, let's see their kinetic energy. Before collision, before the impact, when Q was at rest, means its initial velocity U2 is 0. So their total initial energy, kinetic energy, since no external force acts, so their total initial kinetic energy will be that of ball P alone. That is half m1 u1 squared, which is equal to half times 0.5 times u1. We got that as 12 squared. That gives me 1 over 4 times 144. Okay, so that gives me 144 divided by 4. You know I got 144, that 0.5 is half. So 144 divided by 4 gives me 36. So that is the initial kinetic energy, the total initial kinetic energy of the two masses. Okay, we have found the total initial K before the two bodies collide. Now we want to find the total final kinetic energy of the two balls. We have got our V1 already. Our V1 was given as 3/4 of U1. Okay, that's going to be 3/4 times 12. That gives us 9. Okay, so we use the formula again. Half m on V1 squared plus half m to V2 squared. That is the sum of their K is after collision gives the total KE. So half times 0.5 times 9 squared plus half times 0.5 times 3 squared. That is the final velocity of the second ball. So this gives me 0.5 is 1 over 4, 1 over 2 rather, that gives 1 over 4 times 81 plus this gives 1 over 4 times 9. Okay, so 1 over 4 of 81, 81 divided by 4 equals 20.25. That gives me 20.25 plus 1 over 4 of this, that gives me 2.25. So adding this together will give you 22.5 joules. So you can see that there's a significant difference between the total initial KE of the two balls and their final KE. So at the loss of KE now, the loss of kinetic energy can be evaluated by just finding the difference between 36 and 22.5. So we can even conclude here that the collision is not a perfectly elastic one. It is an inelastic collision. Even if the two balls move off together or move in their separate directions, it is still not a perfectly elastic collision. So the result is 13.5 joules. So the collision is not perfectly elastic because there's still a loss of kinetic energy.